One of the factoring methods that you need in this section is factor by grouping. You'll use this whenever you see 4 terms to be factored. Let's do an example problem. 2cy plus 2by minus cx minus bx. See that we have 4 terms. 1, 2, 3, 4. What you're going to do to factor by grouping is look at each pair of terms separately. There's a pair, and here's a pair. So we're looking at the first 2 terms, and then the last 2 terms. And what we're going to try to do is take out what the first term and the second term have as common factors. So remember, with common factors, I'm looking at the coefficient that would divide into both terms, and I'm looking at the variable and its exponents that would divide into both terms. So from a 2cy and a 2by, I would be able to factor out a 2 and a y. Again, we're ignoring the last 2 terms. We're looking at just the first pair. So then we're looking at what is left from that first pair. If I remove a 2y, I have a c left from the first term and a b left from the second term, and that b is positive. Now I'm going to look at the second pair, negative cx minus bx. And what I'm going to try to do is see if I can match this item that's in parentheses. Would I be able to end up with a c plus b here by taking something out of both of those terms? If you have a minus cx and a minus bx, they have the x in common. And since I'm trying to end up with a positive c and a positive b, what I want to divide out as a common factor is the negative 1x. Now remember, when you factor out, that I could multiply this back and have my original problem. So I can check that a minus x times c would be the minus cx, and a minus x times b would give me the minus bx. So to factor by grouping, I was able to get these first 2 terms and the last 2 terms factored like this. So now, that quantity that these have in common, the c plus b, can be factored out. If I remove the c plus b, I'm left with a 2y. If I remove the c plus b here, I'm left with the minus x. So that quantity, these 2 terms times these 2 terms, is the answer to this factor by grouping problem. Again, I can check this answer. If you multiply these terms out, 2 terms times 2 terms will give me the 4 terms that I started with in the problem. Let's do one more example. Let's look at x squared y minus 5x squared plus y minus 5. Again, you're going to find what the first 2 terms have in common and remove it, and then look at the last 2 terms. From the first 2 terms, I can remove the x squared, which will leave me with the y minus 5. Looking at the last 2 terms, again, I want to try to match up. I want to try to get the y minus 5 to be left over from these 2 terms when I factor something out. However, the y and the 5 have nothing in common to factor out, and it's exactly those 2 terms that I want to try to end up with. So what you do here is you think of this as factoring out a positive 1, because any number has a common factor of 1. So I can take a 1 from the y and a 1 from the 5, and it doesn't change the value of the y minus 5. So then, to go one more step, I can take the y minus 5 out, because both of those terms have the y minus 5. When I take the y minus 5 out away from here, I'm left with the x squared. And when I take the y minus 5 from this term, I'm left with the plus 1.